Zhang from Shanghai Qibao Divided High School. Now I'm going to discuss unpacking a standard. Before I go to the details, I have some questions. What's the standard? How do I know what to teach? And how to teach it? I checked the IBDP math syllabus and I found the assessment objectives. Problem solving is essential to learning mathematics and involves the acquisition of mathematical skills and concepts in a wide range of situations, including routine, open-ended, and real-world problems. Having followed a DP mathematics course, students will be expected to demonstrate the following. The first is knowledge and understanding. That's to recall, select, and use their knowledge of mathematics, facts, concepts, and techniques in a varied of familiar and unfamiliar contexts. And the number two objective is problem solving. That's to recall, select, and use their knowledge of mathematical skills, results, and models in both abstract and real-world context to solve problems. And number three is communication and interpretation. That's to transform common realistic contexts into mathematics. Comment on the context, sketch or draw mathematical diagrams, graphs, or constructions both on paper and using technology. Record methods, solutions, and conclusions using standardized notation, using appropriate notation and terminology. And number four is reasoning. That's to construct mathematical arguments through use of precise statements, logical deduction and inference, and by the manipulation of mathematical expressions. And the last one is inquiry approaches. That's to investigate unfamiliar situations, both abstract and from the real world, involving organizing and analyzing information, making conjectures, drawing conclusions, and testing their validity. And the main topic I choose is about differentiation. Here is the syllabus content. It includes ideas of convergence, limit and continued, definition of derivative from first principle, and the derivative interpreted as a gradient function and as a rate of change. And then it's rules of differentiation. And then derivatives of the commonly used functions, such as the power function, trigonometric function, exponential function, and logarithmic functions. Therefore, implicit differentiation. Derivatives of second cosine cotangent x are the extended differentiation from the basic functions of trigonometric functions. A to the power of x And the log AX are also the extended differentiation for exponential and logarithmic functions. Arcsine, arccosine, and arctangent, that's the extended differentiation from trigonometric functions. And for this topic, the basic concepts students need to know include convergence, limit, derivative, gradient function, rate of change, and rules of differentiation. And for the skills students need to be able to do, they include describe and identify what convergence is and when a sequence is convergent. To estimate the value of a limit from a table or graph, and to understand the gradient of a curve as a limit, and to interpret the derivative as the corresponding gradient function, and to calculate average rate of change and the instantaneous rate of change for a given function at a specific point, and also to make free use of rules of differentiation to find the derivatives for commonly used functions, which include power function, trigonometric functions, exponential functions, and logarithmic functions. And for the depth of knowledge, there are 4 questions students need to consider. First one is close to, the same as, equal to. How do you understand close to? And then is, what's the relation between convergence and limit? And how do you describe the geometric meaning of derivative? And the last one is to point out which rules used when doing differentiation. And for the big ideas, the topic covers the 2 parts. First is connection, and then is the problem solving. And for the connection, it includes the connection between different concepts. And of course, for this topic is related with M8, that's to appreciate the moral, social, and ethical questions arising from the work of mathematicians and the applications of mathematics. That's the debate over where Newton or Leibniz discovered certain calculus concepts, how the Greeks' destruct of zero meant that Archimedes' work did not lead to calculus, and the link to IB learning profile, that's the inquirer, knowledgeable, and thinker. The links to economics, it includes marginal cost, marginal revenue, marginal profit, and market structures. The links to physics, that's kinematics. It involves to calculate the average, for example, average velocity, average acceleration, or instantaneous velocity or instantaneous acceleration. The induced nth and simple harmonic motion. Links to chemistry, it involves interpreting the gradient of a curve. And for the international madness, that's the attempts by Indian mathematicians to explain division by zero. And for the link with the TOK, that is what value that the knowledge of limits have is infinitesimal behavior applicable to real life. Is intuition a vital way of knowing in mathematics? And for the last part, that's the use of technology. We students can use spreadsheets, dynamic graphing software, and GDC to explore ideas of limits numerically and graphically. And for the problem solving is to sketch the graph of a function and analyze the main properties of their function. For the essential questions, students need to understand. The first one is what's the limit? Or how do you understand limit? Before students learn this topic, they should have the knowledge about the convergence of the sequence and also the way to find the sum of an infinite geometric progression. Thank you.